Now let's continue with this program. In Python, we have few more special operators: is, not as, in, not in. Is and not as are complements of one another. In and not in are again complements of one another. These operators are only supported in the Python language. That is, they're not available in the C++ language. Now, with the help of a for loop, we will try to understand what this keyword in or the special operator in does. So first, let's understand how to write a for loop in Python. The use of a for loop is the same as in C++. Whenever we have a set of instructions that we want to execute for a fixed number of times, we will write a for loop. Now in Python, a for loop will iterate through a sequence in a fixed order. Now to create a sequence, we can use an inbuilt function called range. So the range function will take two integer parameters and it returns an integer sequence. The first parameter is the start of the integer sequence. Second parameter is the end of the integer sequence. And it returns us integers that are with a step size of 1. So the default start for the integer sequence is 0. And when we write range 10, we get a sequence that begins from 0 and goes up to 10. 10 is not included. So let's go to the Python console and type range 10. Notice this will return as an object of type range. So range of 0, 10 is the object that's returned. Now let's not worry what list is. I just want to show you what is the content of this range object. So when I write range of 10, all it does is it returns us a sequence of integers starting from 0 going up to 10, and 10 is not included. So we have a sequence 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is the return of this function called range 10. Now think of lists for now as similar to vectors in C++, which holds elements of the same type. So it's an array which holds elements of the same type. Here it's an array which holds a list of integers. Now the in keyword can be used with any iterable object in Python. Now iterable objects in Python are examples of iterable objects in Python are range, list, strings. So with any of these objects, we can use the in keyword to iterate through this object. So the syntax for I in range 10 evaluates as follows. Range 10 will return a sequence of integers starting from 0 up to 10, and I in range 10 will set the value of I to be one of the values within the sequence. So it begins with I to be equal to 0, and then in order the value of I will be equal to 1, I will be equal to 2 in the next iteration, I will be equal to 3 in the next iteration, and so on and so forth. Each iteration, the value of I will move to the next position in the sequence. Now the body of the for loop again begins with an indentation. I'm using tab to indent the for loop, and within the body of the for loop here I'm simply printing the value of I. Notice for loop again ends with a colon. So a while loop, for loop, and an if condition, all the statements, if, else, all these statements in Python ends with a colon. So first let's execute this for loop. So when this for loop is executed, we should see 0 to 9 to be displayed on the console window, which is the value of I at each iteration of this for loop. Next, I'm showing you how to use this keyword in to iterate a string object. A string object in Python is also an iterable object. That is, we can iterate through each element of this string object. So when we write for val in string, the value of this value stored within this variable val will be one character of this string. So at the beginning of this for loop, val will be equal to s. The second iteration val will be equal to t. Third iteration val will be equal to r, so on and so forth until val will be equal to g at the last iteration. So now let's go and print this. So what this says is that we can use the keyword or the special operator in to iterate through an iterable object in Python, and we can use this operator in conjunction with for loop to iterate through a sequence or a string. Next, let's see how to accept inputs from the user. First, let's see what happens with this code. In Python, we will use this inbuilt method called input to accept inputs from the user. In C++, we were including a file called iostream. We then called function called std::cin to accept user inputs. In Python, we simply call this method input and provide a string as an argument, which will be displayed on the console. So let's run this code. Now it's asking us to enter a number, so let me enter the number as 19. Now notice in the for loop, I'm using this value num to create a sequence of integers. However, the type of number is a string, so this code should fail. So now if I try to execute this code, we get a runtime exception. The exception says that we are trying to use a string object to create a sequence of integers, which fails. So therefore, we need to first cast the return value of this method input to of type integer, and now this code will work. Okay. Now let's go and check what is the body of the for loop. The for loop is iterating through the sequence of integers which begins from 2 and goes up to num. That is, num is not included. So every integer between 2 and num minus 1 is part of this sequence. And within the body of the for loop, first we are checking whether num is divisible by I. If num is divisible by I, then the output of this expression will be equal to 0, which we are comparing using this comparison operator equal to. So if num modulo I is equal to 0, we know that num is divisible by I, and we print that the number is not a prime number. So the objective of this code is to check whether the number entered by the user is prime or not. So first, to check whether a number is prime or not, we need to check all the integers that are less than the number starting from 2. Since we know that every number is divisible by 1, we won't check 1. We will check every integer from 2 until number minus 1 and see if any of these integers divides our number. If it divides the number that the user inputs, then we know that the number entered by the user is not a prime number. So we can simply print the number is not a prime number. And here we are using the special statement called break to exit from the loop. Now a break statement is useful when we want to do an early exit from a for loop. Here we know that the for loop should evaluate for a fixed number of times, run for a fixed number of times. However, it doesn't make any sense to continue running the for loop when we know that when we already know the result. That is, let's work through this with an example. Suppose the number that the user enters is 6. First, we will compute this sequence. So we will compute a sequence which begins from 2, goes up to 6. So the sequence is 2, 3, 4, 5. First, we will check whether 6 is divisible by 2. Since 6 is divisible by 2, we know that 6 is not a prime number. And what it also means is we don't need to check whether 6 is divisible by 3. We don't need to check whether 6 is divisible by 4. We also don't need to check whether 6 is divisible by 5. Since 6 is divisible by 2, we know that 6 is not a prime number, and simply we can exit from the for loop. To do the early exit, we will use the break statement. Without the break statement, the for loop will continue iterating until the sequence is exhausted. With the break statement, we can do an early exit and exit from the for loop even before all the iterations are completed. Now, you may be wondering, what is this else here with the for? In C++, we don't have a for with an else. We have else only supported with an if statement. In Python, we can also write else for a for loop. Now, the else will be evaluated when all the iterations of the for loop is completed. So that is, suppose I enter a number which is equal to 5. We know that 5 is not divisible by 2, 5 is not divisible by 3, 5 is not divisible by 4, therefore 5 is the prime number. Now all the 3 iterations were completed, the if condition did not satisfy, therefore the break did not execute, and at the end of this for loop cycle, the else will execute, and we will see that this particular print statement will be evaluated, which says that the number 5 is a prime number. So now let's go back to the code and let's try a few different inputs. So let's first try 19. We know 19 is a prime number. So let's put a breakpoint now here and try a different prime number. So let's try 17. Now notice 17 is again a prime number, so it goes to the else, and current value of I is equal to 16. So the for loop exhausted all the iterations. At the end of the iterations, since the break statement was not evaluated, it went to the else. And when the else is evaluated, we see that 17 is a prime number. Now let's check a non-prime number, and this time let's see what happens. So let me try 9. We know that 9 is not divisible by 2, but 9 is divisible by 3. So when I is equal to 3, num mod I is equal to 0, and the break statement will be executed. Now when the break statement is executed, notice the program execution jumps outside the for loop. So it did not go into the else, it directly jumps outside the for loop. So the else is also part of the for loop, and when the break statement is evaluated, it jumps outside the for loop. And this time we will see a print statement which says that 9 is not a prime number, and 3 times 3 is equal to 9. So let me again just remove all these breakpoints and enter 9, and notice that we see the print statement 9 is not a prime number, and 3 times 3 is 9. Now let's look at the syntax for a while loop. Previously we just looked at while loop when we saw when we worked through the example of multiple assignment statement. Now let's carefully look at the syntax for while loop. It begins with while. Again, you don't have braces. Braces are optional. In C++ you require braces. Without braces you get a compilation error. Here you simply mention a condition. The condition is checking whether I is less than 10. As long as I is less than 10, the while loop is executing. When I is greater than or equal to 10, the while loop will exit. At the end of the condition, we will again write colon. The body of the while loop again has a single tab. There are 2 statements that are part of this while loop. Both of them have 1 tab indentation. The first statement is incrementing I using 1, so I is equal to I plus 1. The second statement is simply printing I. So let's run this code. When this code executes, we should see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to be displayed on the terminal. Okay, now let's check what's the use of continue statement. Previously we saw break. Break is useful when we want to do an early exit in a loop. Break can be used in both for and while loop. Similarly, we can use continue statement in both for and while loop. A continue statement is used to return the control of the loop to the beginning of the loop. So that is, when continue is executed, we will not evaluate anything that is below continue. We will simply jump the program execution to beginning of the loop. So here in this while loop, I want to print all the numbers from 0 to 10, which is an odd number. So to check whether a number is even or odd, we can use the divisibility test. First, I'm checking whether I mod 2 is equal to 0. If I mod 2 is equal to 0, we know that the number is even, so we can simply continue. What this does is it will put the program execution back to the beginning of the while loop. Otherwise, we will print the number since the number is an odd number. So let's continue the execution, and now we should only see 1, 3, 5, 7, 9 to be displayed on the console. So you can use the continue statement to skip a piece of code within your while or for loop. You can use the break statement to do an early exit from the while or for loop. Now, for your reference, I've provided all the bitwise operators that are supported in Python. For bitwise operators, the operand should be of type binary. So if x and y are of type binary, then we can do a bitwise AND. So x and y will do bitwise AND. Similarly, we can use the bitwise OR operator to do bitwise OR, and so on and so forth. Similarly, you also have assignment operators. So you have equal to, plus equal to, minus equal to, star equal to, and every other combination. Now, before we end this class, I want to show you the same piece of code that we started looking at when we began this class with C++, wherein we let the user print his or her name, and then we will print a welcome message using some print statements. So here I'm declaring two string variables, 60054, which is the class code for CS, 6250, which is the class code for ME, and then we will ask the user to print their name, store the response in this variable name, and print a hello message. Notice I'm using the plus operator to concatenate two strings. Here I'm again using plus operator to concatenate two strings. Okay, now let's simply rerun this code. Okay, first let me print my name. My name is Aniket, and notice, so we have hello comma Aniket and welcome to CS6005, welcome to ME6005. So the plus operator, when the operands are two strings, concatenates both strings. So this ends our class on basics of Python.